All right, guys, so today I want to present to you the mathematics internal assessment. Really what I want you to see is that this is not something that is scary or that should be freaking you out, but that this is something that's actually kind of cool that you'll get to do something neat with, okay? So, this video is specifically for HL mathematics, as you can see from my cover page here, but you can also apply these same ideas to SL. SL is graded almost exactly the same way. All right, so here we go. All right, so before I talk about anything else, academic honesty is key. You need to make sure that everything that you do is your own work. Any ideas that you take from somewhere else must be properly cited. This is the same as anything else in IB and actually anything else that you ever write. If you take an idea from somewhere else or someone else, you need to make sure that you cite it. Okay, you can use their ideas. That's fine. It's perfectly fine. The idea of the IA is not to create something that nobody's ever created before. It's okay to use other people's ideas, but you just have to cite that. And when you cite it, you shouldn't be copying everything word for word unless it's very, very clear that that's what you're doing. You should be using your own language as best as you can. And like I said before, you can't just copy something. For the IA, you're not supposed to work with anyone, so it shouldn't be similar to somebody else's IA. It should be your own IA. All of those things are considered malpractice and cheating, and if you cheat on your IA, if you do any of these things, you will get a 0 on your IA with no chance to make it up. Okay, and that's pretty sad because an IA is like 20% or so of your final IB grade, and so yes, it would hurt to get a 0 on that. Okay, so let us continue. The next thing I want to look at is to consider the point of the IA. Okay, why do we have to do it? And this says aims of SL mathematics. It's the same for the aims of HL mathematics. If you look at the IB, they list what their aims are, the purpose of what they're doing. Okay, what are they trying to accomplish in mathematics? And the first 5 things are all very conceptual, you know, certain skills, looking at patterns in mathematics, things like that. Okay, the last 4 read like this. Number 6 is to apply and transfer skills to alternative situations, other areas of knowledge. Number 7 is to appreciate how developments in technology and mathematics have influenced each other. Number 8 is appreciate the moral, social, and ethical implications arising from application of mathematics. And number 9, appreciate the international dimension in mathematics through history and internationalism. Now, some of these things you touch on here and there during your coursework, but for the most part, they're non-existent in the classroom part of your course. Or I shouldn't say that, they're non-existent on the assessment, the external assessment, the exam that you'll take at the end of the 2 years. So the point of the internal assessment is to try to be able to address these 4 things, or a couple of them. You don't necessarily have to show all of them. But one of the things that you want to keep in mind is that this really is the purpose of your internal assessment. You want to try to be applying and transferring skills to alternative situations. You want to take the mathematics that you've learned and use it somewhere else, either to describe a real-life situation or to extend further mathematics or possibly into another subject like a science or a social science or something like that. Okay? The technology, again, you get to use a calculator on paper too, but for the most part, they're not seeing your use of technology. So learning how technology influences mathematics and things like that are very, very good things for what you can do in your internal assessment. All right, move on. These are the criteria for the IA. There's 5 criterion. You've got communication, mathematical presentation, personal engagement, reflection, and use of mathematics. Now, in the next few slides, I'm going to be going through these 5 different criteria, explain how many points each ones are worth, how you get those point values, and hopefully be able to give you an idea of what's going to be required for your internal assessment so that you can start thinking about what you want to do. Okay? So, let's go ahead and look at some of these. All right? Let's move on. Okay, so criteria A is communication. Now, you look at, this is the descriptors and the achievement levels described in the guide for IB, and you can see that they're somewhat helpful, but for the most part, they're very general, okay? Now, the way that this works is that whoever grades your internal assessment will start at achievement level 0, and you will stay at a 0 unless you accomplish number 1. Okay, the exploration has some coherence, and then they'll give you that if it's somewhat coherent. Okay, if it's somewhat coherent, if you can kind of read through it, and there's some organization, you'll move up to level 2. Okay, there's no jumping a level. You have to go from level 0 to 1 to 2 to 3 to 4. If you have things for 4, but you do not have things for 3, you can't get up to a 4. You would stay at a 2. So it's important that you recognize that you have to start at 0 and work your way up from there. Okay, now on all of these criterion, I'm not going to read through the descriptors anymore. They'll be here, you can read them, you can look at them. What I'm going to talk about is practically how does that affect you. Okay, so you see that it asks about organization, being well organized. Well organized means that you've got an introduction, you've got a rationale. There's not a specific setup that you have to have this section and that section and that section, but you do need to introduce your project. Why did you do it? What is the purpose of your exploration? What were you trying to learn about? And then at the end, of course, conclusion. Did you learn about what you wanted to? What were you able to apply it to? What can you do with it? Okay? Coherent means that it's easy to follow, right? You read the first part, the introduction, which leads you into the first step of your exploration. And as you learned about that, that leads into the next step of the exploration, and so on and so forth. So it needs to be logically developed. That's what coherent means, all right? A big part of communication is making sure that your graphs and your tables and your diagrams are in an appropriate place. Okay, don't put them in an appendix. If it's important to the understanding of your paper, it needs to be there. The only thing an appendix is used for is if you need to attach copious amounts of data. But that copious amounts of data should be described in a graph or in a table or something else that is within your paper. The appendix is only for the list of the data. Okay? You should be able to read through your paper and not ever have to look at the appendix if you don't want to. All right? So that also means that if you're talking about a graph in your paragraph, that graph should be on the same page. It should not be, look at the previous page to see such and such graph, or on the next page there's a graph. No, it needs to be in the same place so that it's easy to read. I don't have to be flipping back and forth. Okay? Make it easier. A happy reader means that you're communicating well. Okay? And again, this ties in, it should read well. Should accompany in the appropriate places. Concise, the word concise showed up in the descriptors. Concise means that you are very focused on your aim. Okay, whatever you said was your goal in the beginning, that's your focus. Okay, don't go off on your great aunt or your great aunt's dog or whatever else. Focus on what you're talking about. Don't bring in random mathematical facts just to show off that you know them. Focus on the purpose, okay? If the random mathematical facts help your purpose and help your aim, then by all means bring them in so you can show your mathematical knowledge. But more importantly, you need to be communicating about what you know. Okay, complete means that everything is clearly explained. Okay, no skipping steps, no. It is easy to see that A, then C. No, don't skip anything. Show all your steps. If you're using mathematical equations, then you'll have your mathematical equation. Then over on the side, explain what that mathematical equation is. And then you do some mathematical step, and you explain what just happened. I added 3 to both sides as I'm trying to isolate the variable x, right? Then I take the inverse cosine of both sides, write out in words what's happening so that as we're following through equations, we understand that you understand what you're doing mathematically. Okay? And then again, anything references, citations, that's all part of the appropriate communication. All right, let's move on to Criterion B, the mathematical presentation. Okay, again, very general descriptors. Mathematical presentation is based on a couple of things. Number one, if you're going to introduce new terminology, or if there's just a term that's really, really important that somebody your level may or may not know or remember, define it. Okay, the assumption is that you are sharing this with somebody that is in your class. Okay, somebody who has not done the exploration that you did, but who knows the general core that you know. You don't need to define a derivative. You don't need to define a limit. But if you're going to delve into limits and you're going to delve into how that's affected by calculus or whatever else, then it may be important to include the definition so that you can build off of that. Okay, but generally speaking, you don't need to define trig functions. You don't need to be like, sine is opposite over hypotenuse for a right triangle. No, you don't need to do that. But if it's something new, if it's something that would be helpful to remind them because you're going to build on it, then go ahead and define it. Okay? Use appropriate mathematical language. Okay? Use the right words. Don't say the place that the line crosses the x-axis. Talk about the x-intercept or the zeros or the roots. I mean, use appropriate language as much as possible. This includes your notation, your terminology, your symbols. Okay, one of the things is you cannot use calculator notation. Calculator notation is like using the asterisk for multiplication or using the caret top for a power. Don't do that. That's not appropriate. The E that you see on your calculator, that's calculator notation. You can't use that. You need to write times 10 to the whatever power. Okay? Use proper mathematical notation. Now, one of the things that you have access to that you may not have used before is a software called MathType. If you don't have MathType on your computer, then please talk to me or your teacher because they can get it to you. It integrates straight into Pages or Word or whatever else you're using, and it will greatly simplify your equation. It makes it look much, much nicer. It makes it so that the calculator notation is not necessary. Okay? And so definitely make sure that you have this MathType. Okay? The other part of mathematical presentation is, are you just using equations, right? Is it just equation after equation after equation? Or can you integrate graphs, diagrams, tables, charts, models, that type of thing? All of that is important to your mathematical presentation. All right? In order to get a good score here, some of the things are using technology. That's part of this mathematical area is can you use software, can you use spreadsheets, can you use calculators. Now, not every single assessment will lend to being able to use that, but can you use technology to be able to do something that you couldn't have done otherwise? Remember, one of the aims was looking at how technology affects our ability to do mathematics. So if you can use technology to do something that you could not have done otherwise, or that allows you to deal with copious amounts of data that you couldn't have done otherwise, well, then use it by all means. Again, the same thing as before, define key terms, appropriate degrees of accuracy. We talk about that a lot more in the sciences than we do in math, but just don't make any outlandish claims, and don't round too much, nor don't give decimal places to the millionth place when really all we care about is how many people are left sitting at the table. Okay, so then we got graphs and tables all need labels. That's partly communication, that's partly your mathematical presentation. And then the other thing that's really big is define all your variables. Anytime you use a variable, you need to tell me what that variable is representing. Same thing for the parameters, right? Talk about those letters. What do each of them mean? If I change it, what does it do? Be as detailed as you can so that we understand what each of the variables means and how that affects the results of whatever mathematics you're doing. Okay? On to Criterion C. Yes. Okay, now we're looking at personal engagement. Now, this should be the easiest part of your paper. This is just you being involved in your paper. Okay? Now, as is noted down here at the bottom, it can be recognized in many different ways. Okay? Looking at these things, independent thinking, creative thinking, all those things come down to one thing. Choose a topic that you like. Choose a topic that you're interested in. Please don't choose calculus because that was one of the most mathematically complex topics that we covered, and you want to do something mathematically complex because you think it'll look better. No, choose something related to something that you like. If you like baseball, then come up with something with baseball, even if the mathematics is simpler. I'll talk about that in just a minute. But choose something that's related to something that you're interested in, so it's clear that you're addressing personal interest, so that you want to take the time to think about things creatively. How can I get a video of the parabolic motion of my baseball when my baseball is teeny tiny on the screen? Or whatever it may be. Star Wars. I love Star Wars. I could go on about Star Wars all day. How could I do an internal assessment about Star Wars? Well, I don't know. Maybe I could do something with the firepower of the Death Star versus the firepower of the Starkiller base. Looking at how big they are and the energy density and I don't know. Maybe I could do something with mathematics there with volumes and calculus. I don't know. But do something that you're going to be like, you know what, this is cool. I'm actually interested in what's going to happen when I find the answer to my question. And if you do that, then you will be showing independent thought. You will be more likely to have creative thought, right? And so it'll be much easier to score well on Criterion C. Okay? As you study your topic, ask more questions. Go deeper, right? What if? What if is a great question, especially if you go through your first round and you get some results and you say, well, what if I do this? What if I change this? What if this wasn't the case? What if? Then go ahead and go and study it, apply it. Okay? And those types of questions show your personal interest, and they show your personal creativity, because you're not taking a textbook question. You're taking a textbook question and you're going further. You're saying, well, what if that wasn't the case? What if I didn't know the height of my building? What if I didn't know how fast the bullet was traveling? What if? Though that's a great question for you to ask in your paper, and then go into it further. If you don't have enough time to actually study it, because you're already at the end of your paper and you've written the whole thing and it's pretty much done, postulate. Just make a guess. If I were to do this, if I were to change this, this is what I would have to change about my study. This is how the pattern might change. Okay? Definitely creating mathematical models for real-world situations. A few years ago, there was an internal assessment back in the day when the internal assessment was the same for everybody. You did these two different internal assessments. The internal assessment there was one that was gold medals in the high jump in the Olympics. And it was the height that the person who won the high jump, how high did they jump each year? And they modeled it, and there was a very clear curve, but there were a couple of blips in it. And so the mathematical model was a general mathematical model, but it ended up having to be a piecewise model. You had to break it into two functions, because you had one certain progression, and then all of a sudden, and then this was an interesting part, because then considering historical global perspectives, which is this step right here, if you understood the high jump and you did a little bit of research, you found out that in a specific year, Gene Fosbury came up with the Fosbury flop, which is when they started jumping backwards over the bar instead of forwards. And all of a sudden the model changed. There was a huge jump, a fast jump, and all of a sudden the heights went up again. And then they started to level out again. And then you start to look at technology of personal equipment, how they train, right? If you look at these historical and global perspectives, trying to explain your mathematical model and trying to explain why I had to break it up into three pieces because something weird happened, and then a few years later something else weird happened. There was World War II. Nobody cared about the Olympics for 8 years or 5 years or whatever it was. And so therefore the heights dropped because the most athletic people weren't doing athletics. They were doing other things to support their country during the World War. So, things like that. The other thing that can add into a good score for Criterion C is exploring something unfamiliar. Okay? I've had students do things like line integrals or three-dimensional integrals or some more complicated things with vectors and cross products, or you could definitely apply vectors to a lot of the things that you've learned in physics. Go through the physics book and figure out everything that you've learned in physics and somehow apply it. Applying it, exploring mathematics related to other things, like if you watch CSI, or there was an old TV show, Numbers, it was called, a guy that solved crimes by using mathematics. Is there something like that? Is there some formula that you want to be able to derive or explain or understand that helps you understand how mathematics is used in the courtroom or in sports or whatever it may be? Exploring those unfamiliar mathematics, even though it's not part of your core curriculum, adds to that demonstration of interest in the topic that you're studying and that personal engagement. All right? So obviously I've spent more time on this because this is 4 points that should be given. You should choose a topic that you're going to enjoy studying, that you're going to enjoy developing on, so that this is 3 points. 3 points. Okay, we're on Criterion D. That's 4 of 5, reflection. So now again, just very general for your descriptors, okay? This is how you're analyzing and evaluating your exploration. As you get your data, as you do the mathematical analysis, what do those results mean? Do the results follow from what you expected, or are the results different? Do the results mean something in the end? Are there things that you can do with the mathematics that you learned that you couldn't do before? Or can you see that it's very close to being able to stretch it into something else, but you need to learn something else, right? I don't know, but you have to think back on what you're doing and reflect on your results. Don't just give the results. How realistic are they? Did you have to make assumptions, right? Though a lot of times this is in the conclusion, really, you want to be including these reflections throughout. You want to include it throughout the paper, showing your thoughts and your process. Again, this is going to show your personal engagement as well. All right? On to the next. In order to get a good score for Criterion D, you need to discuss the implications of your results. So what? You found the area of such and such roof. Why is that important? How is it different now that you've learned something? Right? What is the implication of the results? What are the implications of the skills that you learned? What else could be done with it? Right? When you get your results, do they actually make sense? And if they do make sense, who cares? Does it really matter, the results that you found? And then in addition, state limitations, right? Are there physical limitations on your results? If you do something with mathematical models and formulas, are they only valid for a certain time period? Are they only valid for when n is an integer, or can n be anything, or does n have to be positive numbers? And of course, linking to different fields is going to be areas of mathematics is part of this as well. Reflecting, how does this relate to other things that we've done? Okay, so that's Criterion D. Last of all is the use of mathematics. Now, this is where HL and SL are different. Okay, everything else up to this point is exactly the same for SL and HL. Okay, however, at this point, this is where it changes, because for these sections, these 5 and 6, right here at the bottom, those are the ones that are going to be really hard to get. That's where the HLs are being asked to stretch a little bit more. Okay, SL also asks you to do relevant mathematics. It has to be commensurate with the level of the course. I'll talk about that. The mathematics being correct, and showing good knowledge and understanding. That's all part of SL. HL, however, adds in a couple of things. They want you to show sophistication and rigor. Not just that, but they want you to show thorough knowledge. Not just good knowledge and understanding, but thorough knowledge and understanding. It's not enough to just throw in a bunch of equations. You've got to be explaining it. You've got to be using your knowledge to accomplish something. Okay? Now, one other thing is right here, you'll see in 6, precise. Now, notice that it doesn't say precise before that. I'm going to talk about precise on the next page, but notice that there's a difference between correct and precise. Also note that, remember, you have to work from level 0 all the way up. If your mathematics is correct, but it's not commensurate with the level of the course, you're not getting up to levels 5 and 6. You're staying wherever it is that it's not very good. Now, before I go on from this page, okay, it's okay to do something where the mathematics is not super duper high level. All right? If you do, actually, here, let's go on to the next page. This help us understand. Okay, you are expected to do something on par with this course. Okay, you shouldn't be doing simple quadratics. You shouldn't be doing simple trig, simple probability. That's something to be careful of. A lot of students come up with great ideas of, oh, I'm going to do probability of this or probability of that. Probabilities tend to be either very simple or very complex once you get into finding the probability of something where you don't know everything and several things are happening at the same time. Okay, so be careful with probabilities. But anyway, it should be part of the syllabus at a similar level or beyond. Okay, if it's not, then the maximum you can get is 2 marks. Okay, now some of you may want to take that into consideration. In order to those 2 marks, that means you get 2 out of 6 there. If everything else in your paper is good, if you're reflecting, if you're showing personal engagement, if everything else is good and those are the only 4 points that you lose, you still get a 6 on your internal assessment. Okay, so if doing something more difficult is going to come at the cost of everything else, because you're not going to be able to reflect and you're not going to be showing personal interest and you're not going to be able to communicate well, if those things all come at a cost because you're doing something highly technical and highly difficult so that you can get your Criterion E marks, it's not worth it. Okay? It's more important that you are able to show that you can write about mathematics and that you are relating mathematics to the real world or extending your knowledge of mathematics to something new. Okay? So that's the most important thing here. Though recognize that if you do something that's not up to par difficulty-wise, that you can get a maximum of 2 on Criterion E. And that means that your other sections need to be very, very strong. Okay? Use of mathematics, part of this means that you're showing that you fully understand it. Okay? It can't just be, well, I looked up these equations and copied down the derivation. That's not valid. You need to be able to show that you understand. And that's why on the previous slides I was talking about, if you do a mathematical process of equations, then you need to accompany it with annotations explaining what's happening so that it's very clear that you didn't just copy this down from a textbook or from a website or from a magazine, wherever you may have got it. It needs to be clear that you understand the process. Okay? Now, on the previous page, I circled correct and precise. Okay? The math can be regarded as correct even if there's some minor errors. Like you make a couple of little math mistakes, subtraction, addition, whatever. As long as it doesn't detract from the flow of the paper and you still get a reasonable outcome. Now, if you get an outcome that is completely unreasonable, like you find out that my skyscraper is negative 37 meters tall, then you know that you've made a mathematical error, and that would not be correct. Okay? However, if somewhere inside you had some rounding errors or something like that, you could still be granted that it was correct. That would not be precise. Precise means that everything is correct, that you've been very careful with all your calculations, there are no mistakes, everything is clean, correct number of significant figures, all of that lends to being precise. Okay? The other page talked about sophistication and rigor as well. So those are the last 2 things I've got. So sophistication is dealing with challenging mathematical concepts. And this is where I was talking about probability. Probability is difficult to be able to do unless you do something with Bayes' theorem. Maybe you can do Bayes' theorem and how it's used in a court of law to prove innocence or guiltiness or whatever. And guiltiness, I don't think that's a word. But I really don't care. I'm a math teacher, not an English teacher. So I'm going to use whatever word I want. So anyway, you can do something like that. Looking at a problem from different perspectives, maybe looking at different ways to do it. You could do something as simple as calculating the golden ratio or calculating E, and what are some different ways to go about that, and show how it's done graphically, show how it's done algebraically, show how it's done using calculus and limits, show how it's done using some type of Taylor series or Maclaurin series or whatever it may be. And some of those, I know you don't know those words, but as you're doing your research, you may come across those things that may be interesting, so that you can have other ways showing that you can demonstrate it algebraically, graphically, visually, all these different ways. And that is sophistication, okay? And of course, being able to see how different areas are linked together, okay? That's a big part of sophistication. It's not just all about taking a whole bunch of 27,500 different derivatives. That's not what you want to do here. You need to be talking about it, showing your understanding, showing how it's linked to other areas of mathematics. Okay? The last section here is rigor. Okay? And rigor is just the clarity of logic, the language that you're using as you're making your mathematical arguments, tied into the sophistication, but just that it is highly complex in the way that you're using high-level words, high-level logical reasoning, that you're not just walking through, that you're not just using everyday simple language. It's valid for a 12th grader or a university student. It's not talking down to a middle schooler. Okay? So that's kind of your rigor there. All right? Now, I've talked about the different criteria. What I want to do for the last couple of minutes here is talk about how to choose a topic. Okay? The best way to choose a topic is to ask questions. Start thinking about it. What are the things that I've enjoyed the most out of this class? And I didn't say, what have you liked? I said, what have you enjoyed the most? I'm sure that will be very difficult since you love everything about this course, this HL course. But think about what you've enjoyed the most. Think about what you've been the most successful in. Think about whether you prefer pure mathematics, just doing a whole bunch of equations and derivations, or if you prefer something more practical like statistics or modeling, finding a real-life situation and trying to fit it with a curve. Think about if you've seen things in your reading as you've watched TV. I mentioned the old TV show Numbers, which was, like I say, a guy who solved crimes using mathematics and mathematical theory. Is there something from one of those things? Is there something that you saw in a movie once and they were spouting off mathematics and you're like, does that make sense? Or I have no idea what they're talking about, right? So whatever. Think of something that you think is interesting. Think about the career that you want to go into. Do you know what you want to do when you finish here and go on to university? Maybe there's something in that area. I've had students do things with law. I've had students do things with sports. I mean, you can come up with any number of things in any different categories. Think about your interests, your hobbies, something that's going to be interesting. I've had students do stuff with video games before. I mean, there's any number of ways. I mean, most like video games, they all use algorithms. They all use some type of mathematical process to determine how to get from point A to point B, whether it be the difficulty or whether it be how hard the bosses will be or how you advance when you go from one level to the next. Find a model for that progression. And then also Is there something from another class where the teacher said something like, well, here's this formula or here's the concept, but we can't do the mathematics because it's too difficult for this course, or something like that? You could study something like that, right? Or I mentioned physics before. Physics and chemistry both have things related to calculus that are taught in your courses, but that you just don't cover because the average student in those courses hasn't necessarily had calculus when you've been there. So you can use that. I mean, we've talked about some of the calculus. We talked about integrals and derivatives with the kinematics, with velocity and displacement and acceleration, right? We've done all of that. So something similar could be done. Okay? So now hopefully you're starting to think about a topic. Just a couple other notes. There's no page limit, though 6 to 12 pages is reasonable. Okay? If you get more than 12, you're probably not being concise. And remember, concise was one of those important descriptors. If you're less than 6, then you're probably not sophisticated, and you probably don't have the rigor, and you probably haven't gone deep enough. You probably don't have enough reflection. You probably haven't shown your personal engagement. If you're less than 6 pages, you're probably missing a lot. Okay? And I mentioned this before, but this is not a thesis. This is not something where you're studying or discovering something that has never been studied or discovered before. It can be something that you're just learning, a new process that's already there, something that's in the Calculus 2 AP textbook, something that is in one of the options. Maybe you were really hoping to do the calculus option, and we're not doing it. We're doing statistics. You could study something from that option and learn how to apply it to the real world and then present it. So just have some fun with it. It's you learning about something with mathematics. You all like mathematics to a certain degree, or you wouldn't be in an HL class. So find something that you like and take it further. Maybe even if it's something that you learned this year that you didn't quite grasp, maybe that's something you want to do your internal assessment on. Okay? So think about that. Okay? So this page just has some stimuli, basically a bunch of words that are meant to hopefully get your brain moving, thinking about different possible ideas, sports, technology, food. Everybody likes food. Why can't we do something with food? Medicine, right? Various things here, E, pi, golden ratio, any of these things. You can look at many of those things and you can come up with something, I bet, that will be interesting. Come up with your own ideas, okay? Combine one of your ideas with one of these. I don't know, okay? And then last of all, if you're still trying to figure out that topic, what do you want to do? I suggest you do a mind map, okay? This is a mind map that was presented in the Oxford math textbook, okay? And they started with water. They just said, okay, let's choose a topic of water. Now, what do I know about water? What are some of the things that I'm thinking about? Well, I've seen water fountains, right? So water fountains, those are pretty cool. People are always talking about water conservation, right? Do we have enough water? Last week I saw sailing on TV. That's on the water. Looking at rain. What's the difference between a light rainstorm that goes on for hours and a very heavy rainstorm that's over in 20 minutes? Okay, we've been having typhoons here in Hong Kong recently, so I don't know, something about storm surges, right? And then looking at salt content in polar ice caps. I don't know. I don't know why somebody would come up with that one, but maybe somebody that is in bio and bored with life. Anyway, I didn't just say that, or maybe I did. And then from there, you take each of those and say, okay, well, what could I do with mathematics, right? Sailing, you can think of the effect of wind. You can think of the size of the sails, right? You can look at this and you can get an idea, but maybe something like this will be helpful, where you choose a topic, put whatever it is that you enjoy most. Sports, basketball, Star Wars. I made a mind map like this for Star Wars once. I don't know, art. Choose some topic and put it in the middle, and then think of some topics, and then go out from there. As you go out, ask questions. And as you ask questions, think about how math can be used to model it, how math can be used to describe it. Okay? And hopefully this will help you get an idea of something that you want to do. All right? If you'll look on the website, my class website, then I've also included various other things, including some sample assessments, explorations written by students in IB. And so you can look at those and kind of get an idea of some other topics that people have done in the past. Don't necessarily do one of those. It's just to kind of help get your mind flowing and get you to think of some new ideas. All right? That's all I got. I hope that that was helpful and that you have a better idea of what the internal assessment is about. Look at the exemplars and kind of see how each of these things apply to it and how they're commented on and graded on there. All right? That's it.